Remember that sensor that was leaking on that Tiger? Here's a picture of it in its installed location when it was discovered to be leaking on the pressure test. I'm going to go ahead and show you a couple different things. Number one, I'm going to replace the O-ring, and I'll get to that in a second. But this video I'm going to make first is I have the sensor in my hand, so why not test it, right? This had a coolant issue where we have a bunch of missing coolant, so let's go ahead and let me show you how to do just that. I have a factory service manual, and that's going to be really beneficial because it gives me the needed information to test the sensor. I've got a warm engine, which they're not telling us what that is. They're saying it's warm. And then cold engine, they give us 3 temperatures in Celsius: 0, 10, and 20 degrees Celsius, and they give us some own specifications. So if I went ahead and just grabbed my temp gun here, went ahead to switch this to, let's back this up. I went ahead and switched it to Celsius. Inside of here there's a little trigger. So out of curiosity, real quickly, see I'm 79 degrees inside the. Go to my electrical playlist to see a quick video on why that battery indicator could be a big problem. I'll switch back to Celsius. 25, 26 degrees Celsius per the service manual. It does not, that moves us up into what we consider a warm temperature engine. Now I would hardly consider 78 degrees Fahrenheit, 26 degrees Celsius a warm engine. So this would really need to be put in the engine and tested from there. But we could do a couple different things. We could use heat, and I'm going to cheat and do something a little bit different. I got a couple different tools on the bench here. Obviously you got a multimeter. I'm going to check for resistance, and then grab your electrical kit. And what I like to do is take and put a couple connectors in there, so I grab my alligator clips on my meter without having any problems. Here's what you need to know though. These were too small, so I had to take a screwdriver and pry them open a little bit and widening them so that they would fit on the sensor. Don't hurt the sensor when you're trying to test it. That's a big thing too. A lot of people just take and start forcing stuff on electrical connections, and that's a great way to get yourself into trouble. So let's go ahead and see what this tests at the temperature we're at right now. I'm getting 1.698 thousand ohms, the K for kilo ohms. That we're 26 degrees, okay? Important factor is that this chart didn't go that direction. What you did notice about the chart is that the resistance got less and less and less as the temperature went up. So that number should be smaller. The last one we have in the manual is 2.35 to 2.65 ohms at 20 degrees. So if you kind of do some basic math here, you could see that the sensor is in the right direction for resistance. But I'm going to take it a step further. I got a bucket of ice water here. I'm going to go ahead and put this in some ice water and then see what happens here. I've been chilling some ice in here. Should be able to just take my sensor. We do not want these to touch. Now what you're going to notice is, look at that. But look at what's happening is that sensor is just emerged in there. You can see the resistance number going up. I go ahead here, pull that back out. Should have some stability here. 17. I'm at 3,000 ohms. And that is right on track with what the service manual says. Here's the important part. Okay, let's do a little summary here. The important part is the fact that I was able to see that the sensor would change through the temperatures. That's really crucial. Ideally, I'd like to even take a heat gun and go hot and prove that it'll go that direction, but we started hot, so we know that it has that ability. Even as that sensor is just sitting there right now, just hanging out in this hotter shop, and now it's out of the water, you're actually seeing the numbers keep dropping down because it's starting to take the ambient temperature of the room, and that changes that resistance. So that sensor is functioning, it's doing what it needs to, and I can eliminate that off my checklist of potential things that might be wrong with this cooling system problem. If you like what you see here, would you please share it? I'd love you to keep my platform going here on technical education and the ways to be great in your craftsmanship. So keep on wrenching, and we'll see you again in the future. Thanks for being a subscriber and follower of the channel.